Hey everyone, and welcome to the first recorded class of our geometry semester. My name is Mr. Phelan, if we haven't met yet, and I'm excited to work with you. How I'll set up every class is with these objectives at the top and then essential questions. And the essential questions are what you should be able to answer by the end of the class if you have gotten what you were supposed to out of it. And then our objectives for today are foundations of geometry vocabulary and Pythagoras' theorem. We're going to just dive into it a little bit, and then tomorrow we'll finish it off. Questions for today: what is the difference between a line and a line segment, and what does Pythagoras' theorem state and mean? If you were in class today, I asked you to write some information for me on a piece of paper and then drop it into our Dropbox. This is just to help me to get to know you a little bit better. If you weren't in class, please make sure you fill one of these out and then just drop it into our Dropbox inside the classroom when you get here. When you're taking notes in this class, I do recommend you put the date at the top of the paper as well as the unit. If you know like a subtitle for what we're talking about today, you can certainly put it there. Usually if you look at the objectives, you'll be able to tell. If not, just ask me. So today, you saw from our objectives earlier, we are going to be talking about vocabulary and Pythagoras' theorem. Then I'll usually write my essential questions out and I'll leave space to answer them. So leave a little space after each one, and then as you find the answers, you can go back to your notes and fill them in. Shorthand wherever possible. You don't have to write out word for word what's on the slides or what I put up, but you do want to kind of rephrase it, shorthand it. If you hear me say anything else extra in class, you're like, oh, that's really important, or I write some extra notes on the slides, that's something you should probably be putting in your notes as well. And then as you go into the actual nuts and bolts of the class, if you see formulas, make sure you write those down. Any definitions, write those down. If I say a word and you didn't know what the word meant or a phrase, like in the example here, solve the triangle, write a little note to yourself. This means find out all of the sides and angles in a triangle or something like that. If you see me do an example, write down the example, and I recommend you write down the steps as well as to how we got the different answers that we did. So that way you have a full working example with steps for how to get from beginning to end. Any diagrams include those too. Just rough sketches are usually fine. Okay, so let's get started. We're going to do some vocabulary words. Make sure you divide each word away from the next one, because we're going to have a couple of different sections for each one. So you want them clearly divisible so you know which one is which. I'm going to go through these slides pretty quickly in this video. You pause the video as needed to write notes down. Okay, so the first one is a point. This is a specific location, no dimension, represented by a dot. So you'll see the red dot with the P after it. We use capital letters for points, so that's why I have that no capital letters. And dimension refers to measurements. So normally we think of things as having multiple dimensions. So like we live in a three-dimensional world. Most things have a height, a width, and a depth to them as well. Points don't have any of that. They are a specific location in space, so small that they don't have any measurement. They don't take up any space. So it's an odd concept. It's a zero-dimensional figure. And in questions, you'll hear it referred to as point P, or sometimes just the capital letter will be given. Next one up is line. So a line is a connected straight path, no thickness, so it's a one-dimensional shape, and continues forever in both directions. So you'll see it represented using lowercase letters if you're naming the line, and then it'll use the two uppercase letter points that it passes through as another way of naming it. So the two examples down here are line L. So if it's a single letter, it's probably going to be lowercase. Or line AB means the line that goes through the points A and B. You can see my drawing of the triangle up on the top left there. The corners will have points on them, which is why they're capitalized. The side lengths will have lowercase letters to name the sides. So you'd have side A, side B, side C, or another name for side B will be the side AC. So connecting the points A and C. Line segment is a portion of a line, and it has a hard stop at the beginning and the end. So there's a definite beginning and a definite end point. So you'll see referred to as line segment CD, so use the two letters, the beginning and the end one. You can also represent it as the two letters with a bar across the top. And hopefully you noticed in the last one, the letters had an arrow bar across the top, so a bar with arrows on either end. A ray starts in one point, goes on forever in one direction. So think of like rays of sunshine or a laser ray. So it starts at one point, goes forever in one direction. So you'll see it represented using two letters, so the start point and a point that it goes through. And the order which you write the letters is important because it's going to go from left to right. So starting point G goes through H. And same thing when you show the abbreviation of it with the marker above it, the accent, it's going to be an arrow showing the direction of the ray. Opposing rays, if you notice like the diagram I gave you there, you could be mistaken to think, oh, this is a line. It's a line AB or a line AC or a line ABC. It's a line that passes through these points. It can also be described as opposing rays. So you've got the ray BA backing up to ray BC. And it looks like a line, but it could also be described as opposing rays. It's more so if you get told in a question that you have opposing rays, that's what it means. So just kind of keep that in your head for what opposing rays actually means. Next one up is a plane. A plane is a two-dimensional surface that has no thickness and extends forever in all directions. So we usually refer to the horizontal plane, such as floors and ceilings, or the vertical plane, which might be walls. For midpoint, it's the middle point of a segment. So it's got to be first segment. You can't find the midpoint of a line because it doesn't have any definite beginning or end, so you couldn't find the middle of it. But if you have a line segment or the side of a shape, you can find a midpoint. So it's the point which it divides the segment into two equal pieces. You'll see it represented with its start and end point. So in our case here, we've got P and Q. And then if we connect them and we say that point M is the midpoint. Now the way we show that on a diagram is to show that PM is the same length as MQ, and we do that using hash marks. So this is definitely a side note to put in there. Hash marks show segments of equal length. And some examples that I gave in class today were if you think of an isosceles triangle, that's one where two of the sides are the same, one is different. An equilateral triangle, all three sides are the same, or a scalene triangle where you've got three different sides. So the number of hash marks will show which lines are the same length and which ones are different. There's a special verb that goes with this. A midpoint bisects a line segment, and bisect is the verb to cut something in half. So you'll see that word pop up a lot in our word problems and what we're doing in class. We're going to talk about bisectors, so segments that cut something in half. So I want you to really make sure you know if something bisects something, it's going to pass through the midpoint and it's going to result in two equal parts of whatever's been cut in half. So you can bisect an angle, a line segment, or some shapes as well. This is a really fun question to ask in class, but the question I pose to everyone is, what is a circle? Define a circle. And usually what I get back are words like round, no edges or corners, one side or infinite number of sides, and we don't really get to that actual definition of a circle. Usually, like if I try and draw what they're describing, I get some sort of like free-form shape. Like it's no straight edges, it's closed figure, it's one-dimensional or it's two-dimensional, blah, 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 but this is not a circle. So a circle is, you have to have a center point, and it's the collection, the set of all points that are an equal distance away from that center point. So the same distance away. And I'm doing a terrible job of drawing a circle, but oh dear. Yes, I need a tool. So circle, there's my center point. So same distance from the center to the outsides, all points that are the same distance from the center to the outside. So when you add all those points together, or when you complete the collection, you have a circle that would form the outside of the circle, known as the circumference. What else do we know about circles? Circles are two-dimensional shapes. Circles are a regular polygon, which means that all sides and angles are the same. So a circle is one that you can think of as all other regular shapes will fit inside of. So like an equilateral triangle, a square, a pentagon, a hexagon, an octagon, like they will all fit inside of a circle. Circles, I consider circles to have an infinite number of sides. So when you start looking at the ways that the ancient Greeks and so on were developing circles, they were taking shapes like triangles, so 3 sides, square 4 sides, pentagon 5, hexagon 6, hep 7, oct 8. And as you added more sides in, the shape slowly approached looking more and more and more like a circle. So when you hit infinite number of sides, you have a perfect circle. The distance center to the outside is the radius, and the distance across it is the diameter. Okay, next one up is segment addition postulate. And a postulate is something that we accept to be true, but without having to go prove it. So it's something that we kind of base all of our future proofs on. It's that starting point for us. So we are going to look at what's called the segment addition postulate, and that is if you have 2 segments and you put them end to end and you add their lengths together, their combined lengths will be the same as if you went from one end of the segment to the other, so when they're end to end. So nothing is lost or gained by adding them together. So if we were to write it out, the distance from A to B, let's say that was 6, and B to C was 4, we would say that AC is 10. So there's nothing lost or gained by having a point in there or adding them together or subtracting them for that matter. So basically we're saying addition and subtraction also applies to line segments and angles as well. All right, the last thing we did in class was investigate Pythagoras' theorem. So most of you remembered the formula for Pythagoras' theorem, a squared plus b squared is c squared, but very few of you had any idea what it was actually about or what it was used for. So we had an investigative activity where you had to cut out some squares and triangles from a worksheet, and what we realized was that if you had a triangle that was right angle, if you take one side and make a square from that side length, we'll call that A, and same thing for the other side length, this will be a different square, and we'll call this one B, and then you do the same thing for the third side, call that C. That if you took square A, the area of it plus square B, you would get the area of square C. So when we think of the side lengths as A, B, and C, A squared is the square with side length A, plus B squared is the square with side length B, is equal to C squared, the square with side length C. So that is our Pythagoras theorem, where it comes from. So for a right angle triangle, the sum of the squares on the 2 shorter sides is equal to the sum of the square on the hypotenuse. And that's where we left it off. Tomorrow we will dive more into Pythagoras theorem itself and using it to solve for missing sides of triangles. Okay, so our central questions for today: what's the difference between a line and a line segment? A line goes on forever. A line segment is a portion of a line. We kind of misuse those terms a lot in our everyday language. We tend to refer to all line segments as lines, and we don't actually see very many actual lines in our day-to-day life. Pythagoras' theorem is a squared plus b squared is c squared. So the square on a shorter right angle triangle side plus the other square on the shorter right angle triangle side is equal to the hypotenuse square on that side. So hypotenuse is the longest side of the right triangle, so the sum of the 2 squares on a right angle triangle is equal to the square on the hypotenuse. For tonight, I want you practicing your vocabulary and be prepared for a Quizlet activity tomorrow. So you're nothing else that is due for class, just prepare for that.